Okay, I asked you to do on page 570, numbers 7 to 11. Okay, so number 7, barium has a work function of, sorry, I just can't see, of 2.48 electron volts. So WO is equal to 2.48 electron volts. What is the longest wavelength of light that will cause electrons to be emitted? So we're looking for lambda O. First we need to find FO. So we know WO equals HFO. So FO equals WO divided by H. So 2.48 electron volts divided by our H, which by now you should know off by heart, I would think. 6.626 times 10 to the negative 34 joules seconds. Now hopefully when you write this out, you then pause for a second and don't just type it in your calculator. Hopefully you notice there's electron volts on the top and joules on the bottom. So you need to convert into joules here. So you need to multiply by 1.602 times 10 to the negative 19 joules per electron volt. And then you can divide. And when you do this, you get a WO of 5.996 times 10 to the 14th hertz. Excuse me, I said WO, but it's an FO. Once you have your FO, then we know C equals F lambda. So lambda O equals C over FO. C is 2.9979 times 10 to the 8th meters per second. And our FO we just found 5.996 to the 14th hertz, which is per second. So meters per second divided by per second. We'll leave you with meters. And it's 4.9998 times 10 to the negative 7 meters. Okay, so that's our wavelength. Now, sometimes it will say to you, this one doesn't, but it could say to you, what color is this? And if it said that, you would go to this little chart that I gave you on your multiple choice sheet. And it was 4.999, so pretty much 5. And 5 lands in here between 4.9 and 5.7 to the negative 7. So the light that would, the maximum wavelength of light that you would need would be green light. Okay, but it didn't ask you for the color in that question, but I would. Okay, number 8 says, a photocell is used by a photographer to measure the light falling on the subject to be photographed. What should be the work function? So you're looking for the WO. What should be the work function of the cathode if the photocell is to be sensitive to red light, whose wavelength is 680 nanometers? Okay, and that it's giving you the lambda O as well as other colors. Okay, so it's looking for WO, it's giving you lambda O, so first step is to find FO. So FO is equal to C over lambda O, 2.9979 times 10 to the 8th meters per second, divided by 680 times 10 to the negative 9 meters. And when you do this, you get an FO of 4.4087 times 10 to the 14th hertz. Once you get this, now you can find your WO. WO is just equal to HFO. So WO is equal to the 6.626 to the negative 34 joule seconds times 4.4087 to the 14th hertz, or 1 over seconds. And you should get a WO of 2.9212 times 10 to the negative 19 joules. Now, does it ask what should be the work function? It doesn't say in electron volts. Okay, so you could leave it in joules. If it did say in electron volts, then you would, does it say in electron volts? The subject, what should be the work function of the cathode? No, it doesn't say in electron volts. But if it did, you would divide by 1.602 times 10 to the negative 19, and you would get something like maybe 1.8 electron volts or thereabouts. Okay, that's number 8. Number 9 says the threshold frequency, FO, of 10 is 1.2 times 10 to the 15th hertz. What is the threshold wavelength? So C equals F lambda, so lambda O equals C over FO. Better make this a 2. 0.9979 times 10 to the 8th meters per second over 1.2 times 10 to the 15th hertz, and you will get a lambda O of 2.49825 times 10 to the negative 7 meters. Okay, so that's part A. Part B says, what is the work function? So WO equals HFO, WO equals 6.626 to the negative 34 joule seconds times 1.2 times 10 to the 15th hertz. WO will equal 7.9512 times 10 to the negative 19 joules. And it doesn't say in electron volts, so we can leave it in joules. And C says the electromagnetic radiation of 167 nanometers. So this time, this is my lambda of the light, not lambda O, but just lambda. Okay, so lambda is equal to 167 nanometers. So from that we can find the frequency of the light, because we know C equals F lambda, so F equals C over lambda, so 2.9979 times 10 to the 8th meters per second divided by 167 times 10 to the negative 9 meters, and we get a frequency of 1.795 times 10 to the 15th hertz. I'm so used to doing 14 that I was just assuming. Okay, so that's my frequency. If we go on to continue to read, it says, what is the kinetic energy of the ejected electron? So we're looking now for EK max, and we know it's equal to HF minus WO. So EK max is equal to H 6.626 times 10 to the negative 34 joule seconds, F 1.795 to the 15th hertz, minus WO 7.9512 to the negative 19 joules. And you get an EK max of 3.94346 times 10 to the negative 19 joules. What in electron volts? So this time we do then have to divide it by 1.602 to the negative 19 joules. And when you do, you get an EK max of 2.462 electron volts. Okay, that is number 9. Number 10 says the threshold frequency of a given metal, so that's my FO, whenever you see threshold anything, is 6.7 times 10 to the 14th hertz. Calculate the kinetic energy in electron volts of the electrons ejected when the surface is illuminated first by 350 nanometers and second by 550. So part A, lambda is equal to 350 nanometers. Now really this question is almost the same as the above one, it just didn't give it to you in steps. So the first step, you can find your WO, and it's equal to HFO, and we're going to run out of time, 6.626, so I will continue this on the next video.